find the mass m of hanging block in the figure, which will prevent the smaller block from slipping over the triangular block. So find mass m of the hanging block of the figure, which will prevent the smaller block from slipping over the triangular block. It will prevent the smaller block from slipping over the triangular block. All the surfaces are frictionless and string and pulley are light. Okay. So the first thing we should know that if we want to stop this block from slipping on the triangular wedge, so first we will find what will be its acceleration. So we have already done in the last question that thing. So if we have a triangular wedge and we have an object on it, for what acceleration of this system, suppose we write it a naught, this will not slide. So we have already written that was mg, then we had written ma naught, then we had written normal. Okay, these three forces we have written, and to have no acceleration along this, we have to write mg sin theta down the incline equal to ma naught cos theta up the incline. So what we can write is a naught will be g tan theta. So a naught will be g tan theta. So the acceleration of this system will be g tan theta. This whole system will accelerate with g tan theta, only then this smaller block will not slide. Okay, so this condition we have already derived in the last problem. So this is the acceleration of the system. Now, if this is acceleration of the system, the hanging mass will have acceleration, same acceleration. This one will have same acceleration a naught, and now we can write the equation. So for hanging mass m, what are the equations? So tension is upward and mg is downward. So we can write mg downward minus tension upward equal to m a naught. So this equation we can write. Okay. Now for upper masses. For upper masses, if you see, these two can be taken together. These two masses can be taken as one system combined. Why? Because they are having common acceleration. This object is not sliding on the lower one. Okay. So m plus capital M dash together. Why together? Because they are stationary with respect to each other. They are having common acceleration. So what are the forces? The forces are normal from the ground, tension from the left, so tension from the right, normal from the ground, and then weight. So no need to write the tension and weight part, only no need to write normal and the weight part, only tension will work. So tension we can write. So we can write tension will be equal to m plus m dash mass into acceleration. So tension equal to ma. Okay, so this much we can write, and this is equation 2. So if we include these two things, if we add these two, if you add equation 1 with 2, it will be how much? mg minus m plus m dash a naught equal to m a naught. Okay, so what we need to find here is find capital M. So capital M we need to find. So how do we find capital M? So that capital M will be capital mg minus m a naught equal to small m plus capital M dash a naught, or the capital M is small m plus capital M dash a naught divided by g minus a naught. Okay, so m plus m dash, and a naught is how much? G tan theta, and this is g minus g tan theta. So how much we are getting? M plus m dash, and tan theta divided, it will be cot theta minus 1. So in this way we can do. The tan theta will be dividing and it will be cot theta minus 1. So this is the mass of hanging object, which will provide such acceleration so that the small block will not slide on the triangular wedge.